Hello, and we're diving right into it. Thank you for tuning in. Thanks for watching. You're watching lesson 7.6. We are still solving these equations. If you recall from 7.5, we basically had one thing on one side and one thing on the other, and we cross-multiplied to solve. Well, we're introducing a new method to solve, and the reason why we're introducing this new method to solve is because we have a little more going on, right? There's two things on one side of the equation and one thing on the other. And we are going to solve these rational equations by getting a common denominator. So check this out. We already have a denominator that matches there, right? Well, let's go ahead and keep those like so. And then we need to multiply 1 over 1 by x minus 2 in order to get a common denominator. Now, you might have forgotten common denominators, right? We have to multiply by the factor that's missing. If you don't remember that, I would encourage you to watch the beginning of the 7.4 lesson where we added and subtracted these expressions because we had to get a common denominator over and over in those problems. So when I multiply by x minus 2, I end up with x minus 2 on top because 1 times that is x minus 2, and x minus 2 on bottom. Now, the neat thing about this is that once you have a common denominator, because the denominator is the same, we can just ignore it and we focus on the top half of the equation. We focus on the top half of the equation. And now we just solve. Subtract the x and we get 2x. Negative 2 and 6 make 4. And then we divide by 2 and we get 2. Just like the previous problems, we have to check for extraneous solutions or excluded values. And oh, look at that. 2 is excluded. So our very first problem here has no solution. It has no solution. So our strategy is get a common denominator, then look at the top half, so to speak, right? The top half of the fractions. Let's keep it going. 2x plus 5, 2x minus 5, 4x squared minus 25. This, we need to realize, factors into 2x minus 5 times 2x plus 5. It's a difference of squares. 4 and 25 are both perfect squares, so we can split it up into 2x minus 5, 2x plus 5. Why is that useful? Because, well, when we create our common denominators, we only need to multiply by 2x minus 5 on that one, and we only need to multiply by 2x plus 5 on this one, and then this guy's just chilling, right? There's nothing extra we need to do on this one. Now, remember, now that I have a common denominator across the board, I can just focus on the numerator. So I still need to multiply this together, but I'm only going to write the top half at this point. So 2 times 2x is 4x, and 2 times negative 5 is minus 10. Then 3 times 2x is 6x, and 3 times 5 is 15, equals 5x plus 5 over there on the right half. So 4x and 6x make 10x, negative 10 and 15 make positive 5. I need to subtract the 5x over, and I get 5x plus 5 equals 5. That's just going to cancel out, and we're going to have 5x equals 0, so x equals 0. What are our excluded values? Our excluded values are remember, if you don't spot it right away, right, I can kind of see it in my head, but if you can't spot it right away, remember, we're just setting it equal to 0 and solving. So, negative 5 halves is out, and then it's going to give me the same thing except positive 5 halves. So, that's a solution that is included. It is not extraneous, as we call it. I don't know if I did that a little quick, but, you know, just if you got to take a step back and rewind it, then follow my distribution, go ahead and do that. But I think I spelled out every step there. All right, let's go ahead and have our first question here. We need to get a common denominator, right? So, well, maybe not our first question quite yet. Let me get us started here. This, once again, factors into x minus 2, x plus 2, yeah? So when you look at these terms, this guy is only missing the x plus 2, and the second term is only missing the x minus 2. And then, as we know, that guy is just hanging out. And I suppose I can write it so that way it matches exactly. So now, I'd like to just know that you can distribute properly. Let's have some answers on the screen here for the entire expression. You're going to multiply this together and this together. I want to know what the whole thing is multiplied out. So here's a few answer choices for you. You should have got 3x times x, which is 3x squared, and 3x times 2, which is 6x. Then 1 times x, which is 1x, and 1 times negative 2, which is minus 2, equals negative 4. As it turns out here, we have a little bit that combines. We end up with 3x squared plus 7x minus 2 equals negative 4. And guess what? This is a quadratic equation because we have a squared, so we must set it equal to 0 and factor. Now, a is not 1 here. A is not 1. So again, factoring. We had an entire unit on factoring. So it's essentially a skill that we should be good at, but I know it's something that we still continue to struggle with. If you can't factor something, you got to practice more. You got to practice more. There's a million factoring examples out there in the world. How to factor. Examples of factoring. Just there's a lot of resources out there. So when A is not 1, you take the front times the back and you get 6. Then you say what multiplies to 6 and adds to 7. Well, that's easy. 6 and 1. 6 times 1 is 6. 6 plus 1 is 7. So 3x squared plus 6x plus 1x plus 2 equals 0. Then you look at the first two terms and you say, what's the GCF? Oh, they have a 3 and an x in common. You look at the next two terms. What's the GCF? They only have 1 in common. Well, they have a factor that matches. That was the whole point. And we've got the stuff on the outside, 3x plus 1. And there is our solution. X plus 2 times 3x plus 1. Well, not quite our solution, right? Those are our factors, so our two solutions are negative 2 and negative 1/3. Are either of those excluded? Yes, indeed. Negative 2 is excluded, as well as positive 2. So that guy's out. We only have one solution. We have 3 more examples here. This lesson is just as short as the last one. If I'm going to quickly slow me down, rewind me, I just don't like to make these videos too long, and the examples are quite repetitive. Again, let's outline the steps. Number 1, you need to get a common denominator. Number 2, distribute properly. And then 3, solve your equation. Now, that's easier said than done, right? Is it just a simple algebra problem? Subtract a couple numbers and you're done. Is it a quadratic equation? Then you got to factor, right? it can be a little different each time. Tell me, go ahead and look at this right here. I want you to figure out what is the common denominator to this. What is the common denominator that we're going to get? I'd like you to tell me what that is. Here's a few random answer choices up on the screen. So, the common denominator is this 10 is essentially 5 times 2, right? So we can multiply this by 2, but we're also missing the x. So it's missing two things. This is missing the 5 and the 2, aka call it 10, and this is missing just the x. You see that? You see how now we're going to have a denominator of 10x across the board, right? You see that? So we have 60 over 10x, but I guess, well, it's too late now. I've already started writing it. 14x squared over 10x equals x squared over 10x. What I was about to say was that I guess I don't need to write the denominator, but maybe on this one we should, just so you can really see how that combines together. 5 times 2, the 10 times x, etc. So now, again, we don't really care. 60 minus 14x squared equals x squared. You subtract the x squared over. Well, that's kind of weird, right? To have, let's do it the other way around. Let's subtract the 60 and add the 14. I don't know why that's bothering me, but it is. I'd rather do it this way, right? So that way we have the x squared in front. You know what I mean? I don't know. Maybe you do, maybe you don't. And now we factor. Now, this is, there's only two terms, right? I'm stumbling over my words. There's only two terms. Is there a GCF that we can factor out? These are both divisible by 15. I kid you not, right? That becomes x squared minus 4. We divide away the 15, and 60 divided by 15 is 4. And now that is pretty easily factorable. It's x minus 2, x plus 2. So our two solutions are 2 and negative 2. Beautiful, yeah? Is that excluded? No, we're only excluding 0. Remember, excluded values are anything that make the denominator 0. I didn't really say that at the start of the lesson. I apologize. We're 12 minutes in, but it was something that I mentioned several times in the previous video, so hopefully you watched that one and you're like, okay, I remember doing that at least. Two more examples. They're just, you know, same deal. We need to get a common denominator. This factors into x minus 1, x plus 1. So this is 3x over x plus 1 times x minus 1. So now they're going to match. Yeah. Equals 12 over, okay, that guy's already figured out. Plus 2 over 1, and then that needs to get multiplied by both. Now, you might be tempted to want to write that. But the thing is, what is x plus 1 times x minus 1? It's x squared minus 1, right? Like, we took this and ripped it apart. We factored it. Well, you can put it back together for the sake of simplicity over here. You feel me? Right? Why write them separately when we know what they are put together, right? I hope you see what I'm putting down there. Now we're the same across the board. Even though it doesn't quite match up, we are the same across the board. And so now we multiply. 3x squared minus 3x equals 12 plus 2x squared minus 2. Subtract your 2x squared over. The 12 minus 2 is 10, so that's x squared minus 3x equals 10. This is a quadratic, so we need to set it equal to 0. And now how about I have another question for you where you do the factoring for me. What does that factor into? What does that factor into? What multiplies to -10 and adds to -3 is an x minus 5 and an x plus 2. Our two solutions are -5, nope, not -5, +5 and -2. Are either of those excluded? Not at all. We're excluding -1 and +1, but that's it. So this one has two solutions. Is that our first one with two solutions? Oh no, this one did just a second ago. That one had one that canceled out. Yeah, okay. Interesting how that works out, right? Interesting how that sometimes excluded, sometimes not. It's really just the luck of the draw. I'm not really sure if there's a pattern to it. If there is, I'm not seeing it, not off the top of my head. One more time. We're only 16 minutes in. What a lovely short video. Look at this. Let's end with a solid one here. Let's get a common denominator. 3 over x. Let me go ahead and write this out with some space, right? We're clearly going to need some denominators everywhere, to be honest. So these are just 1. This has an x already, so does this one, but it's missing the 3. And then therefore this is missing both, right? And now we'll have 3 x's across the board. So we just focus on the numerator at that point. 9 plus 36x equals 6x plus 4. How about you go ahead and finish that out for me? Go ahead and finish that out for me. 9 plus 36x equals 6x plus 4. This is an easy one to end on, of course, right? We get 30x, and then we need to subtract the 9 over, and we end up with -5. And in the end, when we divide by 30, we end up with a fraction, which hopefully didn't alarm you too much, -1/6. And the only excluded value is 0. No concerns there, right? Again, 3 times 0 gives you 0. Can't divide by 0, so it's excluded. All right. Thank you for watching. It was short, quick, to the point. I appreciate you answering these questions. I appreciate you watching. Of course, at any point, if you have a question, let me know. And I'll see you in class. I'll see you next time. Have a great night. Seriously. Have a good one.